Now, let's look at empirical and molecular formula. Let us just look at the overview here. Let's see what we are going to learn from it here. Now, the actual formula of a compound is its molecular formula. But when you look at the simplest ratio in which the atoms combine, that is empirical formula. This English are too big. Example, check it out. See the chemical formula of glucose. Glucose is what? C6H12O6. You see this formula you see is the molecular formula. It is the actual formula of this glucose. But if I say that, oh, just like what I did in my previous video to explain the concept of empirical formula, that I said, oh, 2 can go here, 2 here, 1. When I was explaining, is that not same 4 oxide that we did something like SN4 plus and O2 minus? Is it something like this, like SN2O4, then 2 here 1, 2 here 2, something like that is what we call empirical formula. If you leave it the way you have it, that's the molecular formula, okay? And actually you should always leave it the way you have it, okay? That division in the previous video was just to explain empirical formula, so take note of that, please. Now, so let's go. So let's look at the concept here. Now, this is the molecular formula. The empirical formula is now for you to take these numbers to the simplest ratio. That is, if you observe, 6 can go in all of them. 6 here 1, 6 here 2, 6 here 1. So this CH2O that you see here is the what? Empirical formula. You can see the simplest ratio at which they combine is 1:2:1. So that's what we call empirical formula. Again, if I have benzene is C6H6. If you observe, 6 can go in both of them. This is the molecular formula, you know that. So the empirical formula was CH. That's the simplest ratio at which they combine. That is, we divide through. Okay, look at this compound, ethane, which is C2H6. If you observe, 2 can go 2 here 1, 2 here 3. So you have CH3. So this simplest one is the empirical formula, while the main one is the molecular formula. The actual formula is molecular formula, and that's what we deal with. Okay, good. Now let's learn the step-by-step explanation on how to find what empirical formula. Thank you. Alright, so let us now learn how to find empirical formula in this video. You see, I'm going to be summarizing steps for you, and most of these steps are what you've not seen before. Now pay attention to it very well with all your mind. Now, the first step is to write the given masses or percentages of the atoms you are given in the question. The question will give you that they can say, okay, you have 6.7% of hydrogen, you have any other percentage they can just give you, 50% of sodium and so on like that. They will give you. Good, write it down. When you write it down, the next step is now to divide by the atomic masses. You'll be given the atomic masses in the question also. Now, when you now divide by the atomic masses, automatically you are converting it to what? To moles. The first step is to write them out, divide them by their respective atomic masses. When you divide them by their respective atomic masses and you write your answer, that answer you got is the mole. Now, when you write down the mole, when you write it down, are you there? The next thing is I will look at each of them that you are having, then divide by the lowest. Divide through by the what? By the smallest mole. Are you there? Okay, so when you divide to get the mole, you now divide by the smallest mole. Then after you divide by the smallest mole, you see, you'll be observing some things. Now, let me show you what you'll be observing. If you see whole numbers like this, 1.2, 2.0, 3.0, all this, or you can see something like 1.01, all these are 1. They are whole number. Just leave them as their whole number the way they are. Now, they say, what to do? Leave it. If you see whole number, leave it. Now, I'm writing this thing because I've observed many questions and I see how students solve this problem wrongly. They solve it wrongly because they lack the effect of this in their memory. They don't know this in their memory. That's why I'm including it here. Now, look at this one. Whenever you have something like 1.5, people will do mistake to make it 2. No. Don't approximate that to 2. I know you were not taught that. Don't approximate that. Mathematically, 1.5 is 2, but you won't use that here. Whenever you have 1.5, you will change it to fraction, and that's 3/2. most of us that we are used with calculations, we already know that, oh, 1.5 is 3 over 2, 0.5 is 1 over 2. Good. So whenever you have this, rewrite it as this. Whenever you have this, rewrite it as this, then you multiply by 2. Also for this, 1.33, you see this 1.3 is like 1.33333333, and do 4 over 3 in your calculator. See, my calculator is there. 4 over 3, you see, you have 1.3333 and so on. So just rewrite that as what? 4 over 3. Also, this 0.3 write as what? 1 over 3. Okay? Then what to do is to now multiply all by 3. You will see examples. Next, 1.67 is 5 over 3. You can cross check that. I'm sorry, my calculator. 5 over 5 divided by 3. 1.6666667. So 1.67, that's 5 over 3. So what to do, I've been giving you here. So 1.25 is 1 over. No, this is not. I'm coming. I have 1 divided by 4 is 0.25. Sorry, this is 0.25. 1 divided by 4 is what? Is 0.25. Okay, but if you check 5 divided by 4 will be 1.25. So 5 divided by 4 is 1.25. Do you see that? So take note of all this. So what to do here is to multiply by 4. Just see what to know. If you want to know what you are going to multiply by, you multiply by the denominator. Here multiply by 4, here multiply by 3, and so on like that. 1.75 is what? No, 3 over 4. 3 divided by 4 is 0.75. This is 0.75. This is 0.75. Are you there? 3 over 4, that's 0.7. So if you have anything like this, okay, so you can observe the pattern. Okay, you can observe the pattern. So just change it to fraction and multiply all by the denominator, and that's all. Now, when do we now approximate? Like I said, there are some things we don't approximate. When do we now approximate? You see, we approximate when that number is very, very close. See 1.99, 2.01, 2.02. All these are very, very near. You can just approximate them to 2. But if you have a number like this, 1.5, don't approximate this to 2, please. Change it to your fraction. 1.33, don't approximate this. Just change it to your fraction, 4 over 3. And 1.25, don't approximate this. Okay? Remember, 1.25 is 5 over 4. Just change it, and that's all. So let's move to problem solving. Okay, we have this question on empirical formula. They said that a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Find its empirical formula. You see, this topic will require you to use what? Calculator. If you're a YX student, you have your calculator. If you're a JAM student, calculator is at the top of the screen, so you make use of them. Okay, so let's look at it. Our first step is to write out what we have. So we have 40% carbon, right? So we have carbon, that is 40%, so you write it out. We have hydrogen, 6.7%, and we have oxygen, which is what? 53.3%. So this is what we have. Now after this, the next one is that, remember, this is the first step. The second step is that what? Divide by the what? By the atomic masses. Are you there? So divide by atomic masses. What we mean by atomic masses is this. You can see the atom that are giving you the mass of each of them. So what do? We say 40 divided by, what's the atomic mass of carbon? That's 12. We say 6.7 divided by, atomic mass of hydrogen is 1. You remove the percentage, don't worry. And this one is what? 53.3 divided by, oxygen is what? I have 16. Did you see that? Good. Then what will that give you? So let's see. So 40 divided by 12, that will give me 3.33. 6.7 divided by 1, that I have 6.7. I have 53.3 divided by 16. What would that give us? That will give us 3.33 also. So this is the first step. This is second step. Now after writing the second step, what do? The next step is now that is to do what? To divide by the lowest. Divide by the lowest. So what is the lowest here? The lowest here is 3.3 now. So divide by 3.3. So 3.33 divided by 3.33. 6.7 divided by 3.33. 3.33 divided by 3.33. What would that give you? So what would that give you? So remember, this and this will give you 1. This one will give you 1. You know, they are the same thing. So let's say 6.7 divided by 3.33. What would that give us? That give me 2.01. Now let us now do some approximation. So tell me, if I have 2.01, can I approximate to 2? 100% yes. Then this is 1. So you can see, therefore the empirical formula is what? Now see what you have here. C is like you're saying C1, H is having 2, H2, oxygen is having 1, O1. But the best way to write it, if you have 1, we just neglect it and write CH2O. So this is the empirical formula. Do you see that? As simple as that. So thanks for watching. Let's move to the second question. Okay, let's solve this question. Work example 2. Find the empirical formula of an oxide of iron containing 70% of iron. So remember, see what we have. Firstly, an oxide of iron have how many elements? 2. Iron and the oxide. The oxide there represents oxygen. Now see this question. We were given only the percentage of iron and we're not given the other one. Next time you see a question like this, just say, okay, percentage of oxygen will be 100% minus 70%, and that is what? 30%. Remember, mathematically, total percentage is 100%. So they gave you 70% by mass of iron. Just like, let me say I have boys and girls in a class. Percentage of boys are 40%. If they ask you what will be the percentage of girls, it will be 60%. How do you get 60? 100 minus 40. That's just what we do. So therefore, let us now write the percentages out. So for iron we have 70%, and for oxygen, what do we have? We have 30%. So the first step is to divide by atomic masses. To divide by what? Atomic masses. So what do we have? So we just say 70 divided by, for iron we have 56. Oxygen, that's 30 divided by, what do we have here? 16. So 70 divided by 56, what would that give you? You have 1.25. 30 divided by 16, what do you have? You have 1.875. So see what you have here. Now next step is to divide by the lowest. Divide by the lowest, or you say the smallest mole. Now when we divide by, which one is the lowest to you? Check it out. Which one is the lowest? Is 1.25. So divide by 1.25. So this cancel this, you have 1. So what do you have? 1.875 divided by 1.25. Sorry, 1.875 divided by 1.25. That gave me 1.5. Aha. So see what we have. See, let me tell you how students will solve it wrongly. One person will say, okay, then this is 1 and this is 2, because this is approximately 2. Then the student will say the empirical formula is FeO2. This is for a wrong student. But for the correct student, what will the correct student do? That is a student that has watched my video very well will now say, no, he did not say it that way. He said whenever we have, this is 1, this is what, 1.5. Whenever we have this, what happens? We will change it to fraction. That is, this is still 1. 1.5 is anything about 3 over 2. Did you see that? Then what do we do here? We will now multiply through by 2. We will multiply through by 2. So multiply by 2. So what do we have? We have 1 times 2, that's 2. Then 3 over 2 times 2. So what do we have? So you know this is 2. And what's this one? 2 cancel 2, and this is what? 3. So remember, this is for iron, this is for oxygen. So therefore, the empirical formula is what? Fe2O3. And that is it. This is very correct. If you remember when we were doing our valency, you see that it makes sense. Iron 3 combined with what? O2 minus. What do we have? See? So this is very correct. Why the other one, where student approximate this one to 2, is wrong. So that's that about that. Thanks for watching. Okay, so see what we have here. We have this question. They said a compound of carbon, hydrogen, and chlorine contains 0.48 gram of carbon, 0.08 gram of hydrogen, and 1.42 gram of chlorine. So what do? The answer that will determine the empirical formula of the compound. Wow. So let's determine the empirical formula. Remember, we'll write out the masses given. So carbon we have here is what? 0.48 gram. Hydrogen we have is what? 0.08 gram of hydrogen altogether. And lastly, what do we have here? Oxygen is how many? That's chlorine. We don't have oxygen here. That chlorine. Cl is what? 1.42 gram of chlorine. Now, what's the next step here? Is to divide by the what? Atomic masses. So divide by the atomic masses. That is for carbon, you say 0.48 divided by 12. We have been given here 0.08 divided by 1. Some will ask me, sir, they always give us, yeah, for your level, you can still have it, yeah. But for pursuit TME, they'll assume that, oh, you should have gotten used to some, but most likely you will be given. So this is 35.5, okay? So punching this into my calculator, 0.48 divided by 12, that will give me about 0.04. This will give me 0.08. Then also this will give me 1.42 divided by 35.5. That's also 0.04. So from here, what do? You divide by the lowest. So divide by the lowest. So what lowest is 0.4? So we say 0.04 divided by 0.04. 0.08 divided by 0.04. 0.04 divided by 0.04. 0.04. So what do you have from here? This will give you 1. This will give you 2. And that other one will give you what? 1. So that's carbon, hydrogen, and chlorine. Now this is what we have after dividing by the lowest. So all these sum we can't, they are just whole numbers, so just leave them that way. Therefore the empirical formula is what? CH2Cl. That's the empirical formula. Now the question gave you something. The question told you something. We check. They said if the molar mass of the compound, you have done question A, if the molar mass of the compound is 99. Wow, let's write it down. So the molecular mass of the compound is what? Is 99. We are now asked to find the what? Molecular formula. So if you want to find molecular formula, guys, look at the step. It's always the same for all of them. You will do you will do like this. Empirical formula times N equal molecular mass. Have this thing in your mind. Okay? So what's my empirical formula? Put it here. CH2Cl, then you bracket N equal to the molar mass you are given, 99. Now let's solve. You know that carbon has been given to you here to be 12. Hydrogen is 1 and chlorine is 35.5. So you put them there. So I have 12 plus, you know, hydrogen is 1 times this 2. So you have 2 times 1. Plus chlorine is 35.5. Good. Then times N equal 99. So if I add everything here together, I think that'll give me 45.9. Let me cross check that. That's 14 plus 35.5. 49.5. N equal 99. So divide both sides by this. So 49.5. 49.5. What do you have? 99 divided by our answer. 99 divided by 49.5. That gave me 2. So therefore, you now say your molecular formula will not be this. You see what you did there? Did it CH2Cl? You know this N that you put here, it is 2. Now use this 2 to multiply all the subscript. You're having C2, then H4, you now have Cl2. You know this 2 times this 2 is 4. And that's all. So this is the molecular formula. You can see empirical formula, molecular formula. Which means that if you multiply this by 2, you get this. That's that for that. Thanks for watching. Alright, let's look at this next question on empirical formula and molecular formula. So look at this question. It's a multiple choice question like JAMB. Now let's see. Empirical formula of a compound is CH2O. Here, you have been given empirical formula. Exactly style of JAMB question. And the vapor density, check. You have the empirical formula. That's CH2O. And you were given the vapor density. You have the vapor density of these compounds to be what? 30. Now you are asked to find the molecular formula. Guys, remember that to find molecular formula, molecular mass is needed. Remember I gave you a formula which is empirical formula times N equal molecular mass. Now the problem is that molecular mass is not given, but we have vapor density. So you have to take note of this formula that what? The molecular mass is equals to 2 times vapor density. If you multiply vapor density by 2, you are going to get the molecular mass. So let's go. This will give me 60. So the molecular mass is 60. So you have 60 now. So therefore, I will now apply this formula here. So what's the empirical formula? CH2O times N equal, what's the molecular mass? We have 60. Input the atomic masses. You can see in this question you were not given. So carbon is 12. You will have known from my previous video. Hydrogen is 1 times 2 plus oxygen is 16. Then times N equals to 60. So what do we have? You know, this will give me 14. 14 plus 16 will give me 30. 30 N equals 60. Divide both sides by 30 to find N. 30 here and 30 here 2. So therefore N equal to what? 2. Now after that, who can now tell me what's now my molecular what? My molecular formula. Molecular formula is this. You know your empirical formula is CH2O times N, and your N is 2. So multiply through by 2. So you have C2H4O2. You can see this type of question. So C2H4O2, C2H4O2. So option B. That's that for that. Thanks for watching.